Howdy there. So in this video, we're going to learn how to complete the square and really what completing the square does for us in terms of graphing quadratics, which is where we're headed and have been over the past couple of weeks. So as we go through this, I want to kind of keep your frame of mind in lens. This lesson is going to be bringing you together a lot of the skills developed over the past few weeks. So we want you to devise a stick with it mentality, that it is hard, but you can overcome it. If you need to, review some of the past week's learning and attend the Zoom meetings if you have questions. Of course, you can always email your teacher if you have any questions. I don't expect you to master all of this. Some of you will, but I do expect you to watch the videos and really to do your best. Stick with it. Some of this can be really challenging, and this is a long video. So what are your tools for graphing? So far we've talked about factoring and then using the zero product property to compute the x-intercepts, and we've sometimes called those roots. And so quickly, just reviewing what that looks like is you're taking a box and you're rewriting it in a different form. So we took the main diagonal and we said, okay, those add up to, they multiply to -8. So we're thinking about things that multiply to -8. And we want them to also add up to -2, -2x. And so what two numbers multiply to -8 and add to -2? So we've got -1 and 8 and -2 and 4. We've got -4 and 2 and -8 and 1. Well, this one adds up to -2, so we've got -4x and 2x, and that adds up to -2x, and it multiplies to -8. We're going to factor, and I'm going through this very quickly, I recognize that, because when we have it in factored form, it reveals something really interesting to us, and we've talked about this over the few weeks. If we set it equal to 0, we can use the zero product property to decide, either x minus 4 equals 0 or x plus 2 equals 0, which implies that x equals 4 if we solved, or x equals -2. And that's really helpful because on a grid, we can see, the x-intercept of 4, yeah, that's a root, and x equals -2 is a root. We kind of have part of our graph ready to go. Well, when we draw a line of symmetry, so we're going to actually do that. When we get it in a factored form, we're going to draw it at 4, because that was one of our roots. I know it says -4 right here, but remember, when we use the zero product property, we find that it's +4. So that's going back to the zero product property if you need to. And our other root is -2 for the same reason. Well, now, there's something in the middle. Parabolas and curves that kind of are like that are symmetrical, which means they have a line of symmetry. And that happens to be perfectly in between these 2 points. So how many spots are there between them? There's 1, 2, 3, 4, 5, 6. So the line of symmetry is going to be halfway in between. So 1, 2, 3. So the line of symmetry, we're going to draw a line of symmetry right down the middle. And this is going to be perfectly in between. So what is the vertex? Remember, the vertex is the minimum or the maximum. It's going to look something like that, but not perfectly. And so we need to find, what is the vertex? Well, the vertex is going to happen on this line of symmetry. So what is that line of symmetry? That line of symmetry is x equals 1, because all the way along this, x equals 1. Well, what happens to the y value when x equals 1? 1 minus 4 and 1 plus 2. 1 minus 4 is -3, so -3 times 3. -3 times 3 is -9. Okay, so on this line, my vertex is going to happen down here at -9, and I don't have enough space, and that's okay, because I'm going to just add on a little line right there at -9. I can find my vertex by plugging in the x value into the equation, and I find that my negative point is at my vertex point is at -9. Well, this is really helpful because now when I go to graph my equation, I can see, the vertex is at -9, and it goes through, my graph goes through this point and through this point. So we use factored form to graph the roots. We can find the vertex by plugging in the line of symmetry and doing that. But remember, we can't always factor it, so we need to develop another way of doing things. I know this went really quickly, so please do come to our Zoom office hours so that you can see another version of this. So one of the things that we're going to be doing that helps us understand this new piece of if we can't factor, we need to find the vertex, or we need to find that line of symmetry, is something called completing the squares. And we need to understand some parts of a quadratic. So pause the video and make a sketch of this quickly in your notebook, and we'll label them in just a moment. So hopefully you've labeled them as best you can. There are 4 parts here, and we're going to label each of those points. So we've got a vertex. The vertex is the highest or lowest point, also known as the maximum or the minimum, but we give it a special name called the vertex. And we also have roots. It's also known as an x-intercept, and we've talked about that. And that's where the line crosses the x-axis. So the x-intercept and roots mean the same thing. And then just like in Algebra 1, we have the y-intercept, and that's the same thing as before. And finally, the line of symmetry happens perfectly in between the x-intercepts. And there's 1, 2, 3, 4 spaces in between the roots, so the line of symmetry should go at 1 because that's perfectly in between the 2 roots. And our line of symmetry is where it mirror images on both sides. So we've got this thing called a perfect square. We're trying, you haven't seen what a perfect square is because we didn't get to it when we were in class, but you'll need to know how to complete the square. And I'll show you what that means. A visual representation actually helps quite a bit. So what I want to show you is we've got x squared plus 12x plus 36. And this is a visual representation of that because we have x squared. And along here, each of these little half yellow blocks is an x, and there are 12 of them. And if you were to spend the time and count all of the little boxes in here, you'd see that all of them are 1. So the length of this side of the box is x, and each side of these is length of 1. And the length of this side is x, and the length of each side of these is 1. So in total, this has a length of x plus 6, times x plus 6. And this is similar. This is the visual representation of the box method we've done with multiplication. Well, we can see that this is x plus 6 quantity squared because it's x times x plus 6 times x plus 6. Well, what happens if we change this situation? Because perfect squares in math, see how this is it is legitimately a perfect square. What happens when we have a perfect square in math that is not? So instead of 36, we have 25. We need to figure out what to do to complete this square because they are so rare in our math classes. So pause the video real quick, how many boxes do we need to complete this square? All right, hopefully you recognize that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares that are needed. Well, we're going to come back to that idea. We need 11 squares to finish this up. We'll talk about that idea in just a moment as we approach the next piece. So I want you to quickly think about this. This is not yet a perfect square, but here's the visual representation of it. How many boxes do you need? How many ones do you need to make this a perfect square? So hopefully you've had a chance to think about what needs to go here. It looks like we have to add 1, 2, 3, 4, 5, 6 more boxes. Well, we can't just add 6 to this. So what's really important to know is that we have this thing. We would like to add 6, but we can't just add 6 because that changes the equation. So what we have to do is we have to actually add 6, add the 6 that we want to add here, but we also have to take away 6. And I selected the wrong thing. We have to take away 6 somewhere. So we're going to actually take away 6 boxes somewhere else. And what that looks like in the equation is we add 6, but we also have to take away 6. Because that's really like doing nothing almost. If I add 6 and take away 6, and we'll talk about why that's important in a moment. So perfect square trinomials always come in this specific form, stuff squared plus 2 times a times b. And if we had more time, we'd explore this a little bit more, but this might be helpful for those of you that really want to tease apart how perfect squares look. Why do we need perfect squares? Well, when we have a perfect square, we can write an equation by looking at the x-intercept, the y-intercept, in this case is at 15. The x-intercepts are the really kind of the opposites of these guys, so at 3 and at 5. And the vertex happens at approximately 4, -1. Well, that's awfully similar to those pieces there. And so we can write the same equation. All 3 of these are exactly the same meaning. They both represent this same curve, but each one tells us something different about the curve. And we're going to dig into this in a future video. It's coming. It's all coming together. There's a lot of pieces pulled together today. So a couple of things you need to know is that there is a thing called a perfect square, and we can do stuff like adding 0, like plus 10 and take away 10. And if I have some number, plus 10, and then take away 10, it's still that number, whatever that number was. It's equivalent. We're not really changing much. And that is a core idea moving forward. So I showed you the boxes. Here's a generic version of those boxes, is that if we have something in the form where the a value is 1, so it's just going to be x squared plus bx plus c, I can take a piece of this, and I can actually split it in half so that I have half of a b, and I have another half of a b. And I'm going to take that, and I'm actually going to move half of it down there. And so I'm going to actually redraw this whole thing. I think I actually have another visual of that. So I've got an x squared, I have a half of a b, and then I have the other half of the b. And then we've got, if I'm thinking about the rest of this square, well, this is the missing piece. Well, what are the dimensions? Well, I've got a half of b here, and I have another half of b here, and using multiplication, this box has an area of half of b times half of b. Or I can think about that as, that's the same as half of b, all of that to the power of 2, because it's the same thing multiplied twice. So when we're thinking about completing the square, we need to have this visual in mind. I'm taking this middle piece, I have the x piece, and I need to add something to make this a perfect square. Well, there's our, I guess I should have shown this, but we've taken it in half and we've split it and we've moved it. But I can't just add this b squared thing. I still have that c. I have to add b divided by 2, or half of b squared. I have to add half of b squared, and I have to subtract half of b squared. This seems really weird, but when you get into it, this stuff right here is the perfect square, and you're actually left over, when you combine those, you get the perfect square. Those pieces, and I'll show you what I mean. I'm going to do it. This is a very high-level overview, and I'll show you the specifics in just a moment. So a trick that always works is, remember that we're taking that b term, we're cutting it in half, we're squaring that, and then we're adding and subtracting that into the equation to make a perfect square. This only works when the leading coefficient is 1. We'll talk about what happens when it's not 1. So I'm going to do this. I'm going to do this problem. So remember, the b value is 8. Half of b, so b divided by 2, half of b is 4. And then half of b squared, all of that squared, so 4 squared is 16. Okay? And we're adding it in and taking it out. So I'm going to copy most of it, x squared plus 8x. I'm going to leave a bunch of space. I'm going to actually move that 10 to plus 10. Remember that we're adding 16 and we're subtracting 16 because this piece is the perfect square stuff. In fact, if I were to factor this, it would be really nice. It would be x plus 4 times x plus 4. And then we've got this extra stuff. We've got this extra garbage. And 10 minus 16 is negative 6. So we've got this garbage. But this is our perfect square. X plus 4 times x plus 4 is x plus 4 squared minus 6. So we've completed the square. I'm going to do a couple extra problems with you. We're going to take the b value, the middle piece, going to cut it in half and square it. So if you want, pause the video. If not, watch along. We have our b value. The b value here is 4. We're going to take b, we're going to cut it in half. So half of b is 2. And then we're going to square it. Half of b, all of that squared, is 4. And we're going to add and subtract that. So I've got x squared plus 4x. We're going to move the 11 over. We're going to add 4, and we're going to subtract 4. When you factor this, you get x plus 2 times x plus 2, and when you combine these pieces, you get 11, 7, so plus 7, and then we get x plus 2 quantity squared plus 7. Okay, and this is the it's called vertex form, but it's for completing the square. So that's the answer that we want to get to because it's really helpful as we start graphing. All right, I want you to try these on your own. In fact, they're going to be the first 2 questions in this week's activity, and I will show you how to do them. But please do try them on your own first before you do them. Remember, you're going to find the b value, you're going to take it, and you're going to cut it in half, and then you're going to square that answer. So you're going to take that, and you're going to raise it to the power of 2. And you're going to do that for both of them. All right, hopefully you've paused the video and have given it a try. We're going to take the b value. The b value here is 5. We're going to cut it in half. So half of 5 is 2.5. And we're actually going to raise it to the power of 2. So 2.5 times 2.5 is 6.25. This is weird, but remember we're going to add and subtract. So we got x squared plus 5x. I'm going to do that in a different color, sorry. X squared plus 5x plus 2. Remember, we're going to add the 6.25. We're going to subtract the 6.25. If you were to factor it, here's a hint. X minus plus 2.5. X plus 2.5. The 2.5 is coming from here. And then we've got all of our garbage kind of left over. I call this garbage. But 2 minus 6.25 is negative 4.25. So the factored form is x plus 2.5 squared minus 4.25. And this is your answer. If you haven't tried the last one on your own, pause the video, try it, and then come back and watch the answer. I'm going to do it without talking, hopefully. Here we got negative, we'll talk, fine. Negative 7, half of that is negative 3.5. Negative 3.5 times negative 3.5 is positive 12.25. So x squared minus 7x, move the 21 over, it's plus 21. We're going to add 12.25. We're going to subtract 12.25. This piece is our perfect square, so it's going to be x minus 3.5 times x minus 3.5. And then the leftover stuff, 21 minus 12.25, is positive 8.75. So this is x minus 3.5 quantity squared, because it's the same thing multiplied twice, plus 8.75. I know this is long. Thank you for making it to the end. Keep practicing this. It's not as hard as it looks, but there's a big concept to it.